All right, this is 5th grade, Module 5, Lesson 10. And in this lesson, students are going to be finding the area of rectangles. And the thing is about these dimensions of the rectangles, one of the dimensions is always going to be a whole number. The other one is either going to be a fraction or a mixed number. The idea is, yes, we're kind of looking at area, but the real underlying important concept is multiplying fractions. And ultimately, we're going to have our students multiplying two mixed numbers using that standard algorithm. But at this point, we're going to be using geometry as the context so that students can get the answers without really using that standard algorithm yet, because really what we want students to do is to develop understanding of the math before we go ahead and just give them an algorithm, because we don't want the students to just blindly follow a rule. We want it to make sense. So let's get started.
So a key thing in this lesson, parents and teachers, is that we are going to be tiling our fractions rather than just using repeated addition. The idea is we know, like if we're going to look at 3 units by 2 units, so when we think about 3 times 2, we could think of this as 3 copies of 2. So we could think of this as 2 plus 2 plus 2. And consequently, down here, we could think of 3 units times 2.5 units. We could think of that as 2.5 plus 2.5 plus 2.5. And that's just the idea of repeated addition. So the idea is, well, why do we want to do something else if we could just use repeated addition? And the idea is because we're setting the stage that ultimately will allow students to use a method that will also get the answer if we're dealing with 2 mixed numbers. For example, this repeated addition idea only works because one of the dimensions is a whole number. If both of them were mixed numbers, you could no longer easily use repeated addition. We have to move over to some new idea. And that new idea is what this lesson is talking about, which is tiling. So we want to think of 3 by 2 as a length of 3 and a height of 2, and we really want students to think of it like this. So when we think of 3 units by 2.5 units, what we want students to think about is we want them to think about, and I want to get rid of this guy because I don't need it anymore. And we're going to think of this 3 units by 2.5 units. Here's our 3 units, and then here's our 2.5 units. So the 3 is pretty straightforward. Here's our 3 units. But the 2.5 is going to be like 1, 2.5. So there's our 2. So we could think of this as 1, and this is 1, and here is our half. And the idea is this is 1, this is 1, and this is 1. And so that helps us get our areas. So what's the area of this? Well, that's 1 because it's a length of 1, a width of 1. So that has an area of 1. This 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 has an area of 1. And this has an area of 1. And then finally, what do we have? Well, here's a half. Now, how do we know it's a half? Well, because its length, let's call it, is 1. The height is a half. So 1 times a half is a half. Similarly, we've got a half right here, the half square unit, and then we've got another 1/2 square unit right there. So we have all these square units right here, and then half a square unit, half a square unit, and a half a square unit. Well, of course, we could take that half and a half. These together make one whole. So we could gather these two together to get one whole. And so now we can see that our answer to this problem is equal to 1, 2, 3, 4, 5, 6, and then together this is 7 plus a half. So our answer is 7.5. And we got it through tiling rather than through repeated addition. In this case, I think repeated addition would have been quicker, but that's not the point. We are setting the stage over here so that students can use the standard algorithm for multiplying a mixed number by a mixed number. And so that's why this effort is going to be, this work over here is worth the effort because it's laying the groundwork for the standard algorithm. So doing a little bit of practice, we're going to look at this and we're going to see that we're looking at, we are looking at this rectangle right here. And what's the length? The length is this direction, and we can see that they're telling us right up here, and I'm going to zoom in, they're telling us that the length is 2¼ units. So I'm going to zoom back out. So the length is 2¼ and then the width, this piece, is 4. So now what we're going to do is we need to find the total area. So we're going to use logic. Well, if this is 4, that means each one of these is 1, and then this is 2¼ so each one of these right here is 2. So each one of those is 1, I mean. So I'm going to zoom in a little bit here, and I'm going to zoom in and say, well, that means this guy right here is a 1. Why is it a 1? Because it's 1 wide and 1 length. The length is 1, the width is 1, so it's 1 unit, 1 square unit. And then similarly, here's 1 square unit, 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 and 1 square unit. So you see that's where they get 8 square units. 8 units squared, or 8 square units. So we have 8. Now what's over here? Well, we know that this is 1 unit high and it's 1/4, 1/4 wide. So 1 times 1/4, that gives us 1/4. And I'm going to use a slightly thicker pen here. And so that's 1/4. All right. And then similarly, here's a 1/4, and here's a 1/4, and here is a 1/4. So how many fourths do we have? Well, we have 4 fourths right here. 4 fourths, that equals 1 whole. So we have 8 units, 8 squared units. Really, I'm going to call this 8 squared units, or units squared. And then plus we have 1 more squared unit, or unit squared. How do we know? Well, because we've got fourths here, and we have 4 fourths, and 4 fourths equals 1 whole unit. And so now I can zoom back out so that we can see the rest of the thing. And so these 8 right here plus this 1 right here means we have 9 square units as our area. So that's the idea. Kind of feels cumbersome at this point, but it's because we're laying the groundwork for this standard algorithm in the future. Now they've removed some of the scaffolding and we don't have the picture, but we're told that it's 3/4 units long and it's 4 units wide. So that means it's going to be tall. And I'm not going to draw this perfectly to scale, but there is our 4 units right here. Is that it? 1, 2, 3, 4. Yeah, there it is. So there is our, oh goodness gracious, I don't like the way that looks. Let's try again. So here's my 4 units wide. So boom, there's my 4 units wide. But the length is 3/4. So it's not going to be 1 whole. It's going to be 3 pieces. So what that means is, that means we're going to have, and I'm going to kind of insert this in blue. So these are quarters strips. All right, and so I'm going to make this in black right here. So the idea is this is 1 unit tall. This is 1 unit tall, 1 unit tall, 1 unit tall. Now, right down here, this entire length is 3/4 of a unit wide or long. But each one of these is a quarter, isn't it? So this is 1/4, this is 1/4, and this is 1/4. So if we wanted to, we could look at the area of this little wedge right here. Well, it's got a height of 1. It's got a width of a quarter. So 1 times a quarter is a quarter. And anything times 1 is itself. So that's really kind of cool. It's 1/4, because 1/4 times 1 is 1. I mean, 1/4 times 1 is a quarter. So there we go. We got our little piece right there. Now, in fact, I can move it if I wanted. Okay, so all of these are a fourth. Isn't that true, right? So here's a fourth, here's a fourth, here's a fourth, here's a fourth. Well, these 4/4 right here, that equals 1 whole, doesn't it? Because 4/4 equals a whole. So here, that piece right there counts as 1 whole square unit. And similarly, if we wanted to, this piece right here is 1 whole square unit, because the fourths put together to equal one full square unit. And then here, lastly, right here, this is 1 full square unit. So our answer is 3 square units. Now they're removing the scaffolding even further, and they're giving us some practice with a word problem. So it says, let's see, what does it say? It says Rachel made a mosaic of different color rectangle tiles. 3 tiles measured 3.25 inches by 3 inches. 6 tiles measured, oh my goodness, 4 inches by 3.25 inches. What is the area of the whole mosaic? Well, let's draw one of these and one of these. So let's get started with that. So the first thing is, it's this one, let's do it, is 3.5 by 3. And we're not going to worry about the proper orientation. I'm going to draw this, let's see, 3 by 3.5. So let's see, it's going to look like, here's 3. And so that's my 1, and my 1. So there's my 3 inches. And now I have to draw 3.5. So let's see, I'm going to do 1, 2, 3. So I'm going to call that one, that one, that one, and then here's a half. All right, and then let's draw this next one. Let's draw this one. So it's going to be 4 inches by 3.25 inches. And I'm going to draw it in the same kind of orientation for whatever reason. I kind of like to have my mixed number down on the bottom and my whole number on the side. I don't know why. That's the way I do it. It doesn't matter though. So parents and teachers, let your students tweak it any way they want. So we're going to start by doing the 4 inches. So there's my 4. 1, 2, 3, 4. So there's 1 inch, 1 inch, 1 inch, 1 inch. So there's the 4 inches. Now I have to do 3.25 inches. So, oh my goodness. So that's going to be 1, 2, 3.25. So there's 1, 1, 1, and there's my quarter. So now I've drawn them, and now let's go find the area of each of these tiles. So this tile, this mosaic tile, if I wanted to find all of the little areas, this is 1 square unit, 1 square unit, 1 square unit. So I'm going to add up all these square units. And then, but this piece right here, that's a half square unit, because it's 1 high and a half wide, and 1 times a half is a half. And then this is a half, and this is a half. So if I wanted to count all of this, I can see I've got 9 square units here. 2 halves equals a whole, so that's 10 and 10 plus an extra 1 is a half. So I've got 9 here, plus these 2 makes 10, plus the half. So this is 10.5 square units. So I'm going to put units squared. In the same kind of way, let's do this other rectangle. So all of these are ones. 1 square unit, 1 square unit, 1 square unit, 1 square unit. And parents and teachers, pay attention to the fact that these are square units, but these are just units. So don't let your, in this case, they're inches. So don't let your students get all confused and think that this one and this one are the same. These are linear inches and these are square inches. And then using that same logic though, here's a fourth, here's a fourth, here's a fourth, and here's a fourth. And how are they a fourth? Well, because we kind of did the same math that we did over here. This is 1 times 1 gives us 1 square unit. So over here, it's 1 times a fourth is 1/4 square unit. Now, if we were going to count all the units, square units, we see that we've got 12 square units here. That's pretty straightforward. There's 12 square units. But then these 4 fourths add together to get 4 fourths. So now we have 13 square units. So that's our math that is necessary for 1 tile. But we have 3 of these. So we have 3 of these. And similarly, we have 6 of these. So if we wanted to get our answer, well, 3 times 10 is 30. And then 3 halves, that's equal to 1 and 1/2. So altogether, that gives us, let's see, 31.5 square units. Same kind of work over here. We need 6 of these 13 square unit tiles. So 6 times 13, that's easy. That's 678. That's 78 units squared. And now what is the area of the whole mosaic? Well, all we have to do is take this number and add it to this number, and that's our answer. I'm going to let you guys do that on your own. The last problem for this video, a garden box has a perimeter, oh my goodness, of 27.5 feet. So the perimeter, that means it goes, that's the distance around the rectangular box. If the length is 9, what is the area of the garden box? Oh my goodness. So, well, first thing we should do is we should draw this. So let's do it in brown, because to me, when I'm thinking of a garden, I'm going to think of brown. And I might not draw it correctly. We're definitely not going to worry about drawing it in proportional, in the correct proportion. So let's just draw a garden. It should say a rectangular garden. It says a garden box, kind of is making us assume that it's a rectangle. It could be a circle. Couldn't a garden box be a circle? I don't know, whatever. So we're going to assume that it's a rectangle. And the perimeter is 27.5 feet. And the length is 9 feet. And so that means up here is 9 feet. But the question is, what is this width and what is this width? So basically what we know we have is we have 9 plus 9 plus a question mark plus another question mark equals 27.5. And I should put in feet, but I've run out of room. So really, that's 18 plus, now I'm going to be a little bit more thoughtful, and I'm going to put 2W equals 27.5. And what does that mean? I'm saying basically 18 is because 9 plus 9. And then 2W is, I'm thinking of 2 widths. I've got a width here, I've got a width here, so I'm going to call that 2 widths, or 2W, 2 times the width, because I've got 2 of them. And so I can see that, oh my goodness, well, if I know that 18 of my 27.5 feet is taken care of, right? So that means my 2 widths must be, let's see, 9.5. Now, how did I get that? Well, if all the way around is 27.5, and I already know 18 of it, so I just subtracted these 2 guys, and I got 9.5. And so that means this width plus this width has to equal 9.5. So I have to cut this into two equal-sized pieces because that's this width plus this width. So if I cut that in half, I'm going to get 4 3/4. How might parents and teachers, you might say, well, how do we show that? Well, one way you might show it is you might say, well, let's take 9 1/2 and break it up into 9 1/2. And then if I want to cut the 9 1/2, I'd cut it in half. What do I get? Well, that's 4 1/2 plus another 4 1/2. Whoa, 4 1/2. And if I wanted to take this half and cut it in half, what would I get? I'd get a 1/4 and a 1/4. So if I want half of 9 1/2, because this is 2 of them, so I only want half as much, well, I take 4 1/2 and I take a 1/4. There's my half. And if you add 4 1/2 plus a 1/4, you get 4 3/4. Whoa, 4 3/4 right there. So the width right here, 4 3/4. And this width is 4 3/4. And so the area, but the question is, what's the area of the garden box? Well, the area is found by doing 9 feet times 4 3/4 feet. So we're going to multiply the length times the width. So I'm going to move this. So 9 times 3/4. So here's my 9 times 4 3/4. So what is that going to look like? Well, 9 is right here. 4 3/4 is going to look like this. So I'm going to do a little bit of shortcut. I'm going to call this 9. And I'm going to call this 4 3/4. So what's the area of this piece right here? Well, that's going to be, the area of that piece is going to be 36 feet squared. Now, how did I get that? Well, I got that because the length is 4, the width is 9. 9 times 4 is 36. So it's 36 feet squared. Now, over here, what am I going to have? Well, I'm going to have 3/4 and another 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 3/4. I'm going to have 9 3/4 right here, right? And so 9 3/4. Oh my goodness, what would that look like? Well, a way to think of it is I'm going to have 9 copies of the 3/4. And so that means I'm going to have 9 times 3/4, which is 27/4. And that 27/4 is equal to 6 3/4. So that means this area, let's see, right here is 6 3/4 feet squared. My goodness. And so what's the total area of this entire thing? Well, I'm just going to add 36 and 6 3/4. So if I'm going to add those two guys together, I need to add 36 feet squared plus 6 3/4 feet squared, and that gives us 42 3/4 feet squared. And that is a doozy of a problem. So real quick, what did we do? We used logic, a little bit of algebra, to try and figure out what are the missing widths, and we had to do a little bit of thinking. We had to cut 9 1/2 in half to figure out that, oh, each width is 4 3/4. That should be a 4 right there, 4 3/4. And then we knew that that meant we can multiply 9 by 4 3/4 to give us the area of that new rectangular garden, and it's 42 3/4 feet squared. That wraps up a doozy 5th grade Module 5 Lesson 10, where we are learning how to multiply, and ultimately we're going to learn how to multiply two mixed numbers using that standard algorithm.